Hi, Calculus 3 students. So in these following up 2 or 3 videos, we're going to tackle the exercise at the end of the section 11.11 in which we're discussing Taylor polynomials and their use in approximating function. So the exercises that I have here has 3 parts, but we're only going to do the first part in this video, and then we're going to leave parts 2 and 3 in 1 or more other videos. So first part, find the third degree Taylor polynomial t of 3 for f of x is equal to x ln of x centered at x equals 1. So this is the easy part, because to find the Taylor polynomials, you can do many things. I think what I would do is I would go with taking derivatives. I think this is the simplest way to find this one. And the reason is because it is centered at x equals 1. So it's going to be a polynomial with terms looking like x minus 1 to the power of n. And we're multiplying in x. So it's possible to use known series in order to do this, but taking a couple of derivatives, I think, is the right way to go here. So, all right, let's do it then. So we have f of x that's equal to x ln of x. Remember, what you do is very simple, is you find first the derivative and you evaluate it at 1. So I'm going to put here a very big arrow. Let's put it like big like this, let's say, because the derivative will involve a little bit more work. So f of 1 here is 1 times ln of 1. And remember that ln of 1 is 0. So f of 1 is equal to 0 here. Then let's find some derivatives. Remember that you have to use the product rule here. So you're going to have ln of x plus x times ln of x, x times 1 over x, sorry. So let's just write this because I don't want to mess up. But that's what I thought, ln of x plus 1. Okay, so this is the first derivative. So f prime of 1, as you can see, is going to give 0 plus 1, which is 1. Now, f prime prime, now all the subsequent derivatives are very easy because the derivative of 1 is 0. So derivative of ln of x is 1 over x. Okay, so here you will have f prime prime of 1 is equal to 1 over 1, so 1. And f prime 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 of x, so that will be negative 1 over x to the power of 3, x squared, sorry, there you go. So that's this derivative, meaning that f triple prime of 1 is going to be equal to negative 1. Okay, so now we have to find the third degree Taylor polynomial, so we don't need to go any further. We will have to find the fourth derivative eventually, but since we don't need it now, I will postpone it. So, okay, T3. So pretty much it's going to be C0 plus C1 x minus 1 to the power of 1 plus C2 x minus 1 x squared plus C3 x minus 1 to the power of 3. Remember here that Cn is the nth derivative at 1 over n factorial. So now let's fill that in. So C0 is going to be 0, so it's only f of 1. So that's going to be 0. C1 is going to be 1 over 1 factorial, so just 1, times x minus 1. C2, okay, so that's going to be 1 over 2 factorial. So 1 times x minus 1 squared over 2 factorial. And of course, 2 factorial is just 2. And finally, C3, so that's going to be negative 1, right? Negative 1 is the f prime 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 of 1. so x minus 1 to the power of 3. And this is going to be over 3 factorial. So overall, let's just clean it up, and that's going to be it. We're going to write x minus 1 plus x minus 1 squared over 2 minus x minus 1 to the power of 3 over 6. So that's our T3 of x. I hope that the video was helpful. See you in the second part of the exercise where we use this T3 of x and we calculate the error inside some interval. Let's see each other there.